Buddy. So I'm going to try to show you how to get your own version of a working Python environment on your local laptop. Now, obviously we've got DataHub. DataHub is highly convenient for every assignment you're actually going to do in the class, that kind of thing. You can even do your projects on DataHub. But let me be blunt, DataHub goes down at least once a quarter. And it's more likely to have problems at the end of the quarter when everybody is trying to get stuff done right up against deadlines. Now, especially if you're going to do projects that require bigger computation than what we've given you on DataHub, maybe you've got a machine, a laptop, or a gaming rig that is very powerful, and you would like to do your project work on your local machine. Well, great. That's why I'm showing you how to get this local installation here on your own computer. Now, how are we going to do that? Well, I want you to note that when you log into DataHub, you're going to be faced with a menu like this one. It'll be a little bit different because you're not me. But one of the options you're going to see when you log into DataHub is certainly going to be our instance of COGS 108. Now, before you click yes and go for this, right, I want you to note something right here. See this? This is an address. That address links to an image of a Python environment. And we are going to steal that image. We're going to use it for your local machine. And we're going to install from there. So I'm going to suggest that you highlight this HTTP address and you hit Control-C or Command-C or whatever the proper thing is for your thing, your particular operating system that does a copy. And we will be using that address here in a second. Now, the way DataHub works is when you launch the environment, what it does is it opens up what's called a Docker container on a set of machines in servers in UCSD, okay? And when you log in, instead of this, what you're gonna see is this, right? This is notebooks, right? You can click on a terminal to get to where I just was. And this is all a complete set of Python and other things running on a computer at the Supercomputer Center in UCSD. And the key element is this container, this Docker container. Well, that's just a list of instructions about what to put into this container. What kinds of operating system, what kinds of Python, exactly which versions of all these different libraries is all defined by something called a Docker container. Okay. So Docker, let me click over to this tab. Docker is an application which lets you run a completely isolated instance of any kinds of operating system and programs together. Here's the deal, right? You make some software and it works today on this exact operating system on your laptop and this exact set of Python version 3.12 point whatever, and it works today, this software you made, on that platform. But maybe you want to run this software on somebody else's computer, or maybe you want to run this software in 7 years when Python is completely different. All kinds of things have changed. The operating system has changed. Things your software is relying on may no longer be available to you because software is always changing. So a tool like Docker, it is a lightweight container system, is what you call it. It contains, in every image, every container, it has an operating system. It has a set of programming tools or whatever else you set up to have in the container. And if you distribute your software with its own operating system and its own setups for software development, Well, it's always going to work. It's going to work on your neighbor's computer, even though it runs a different OS. It's going to work on your computer in 7 years from now, which is completely different, because you're distributing every single thing you need along with the software itself. So that's what Docker is, right? What you're going to want to do, if you haven't already, is download Docker Desktop for yourself. Whatever you need here, you download it. And once you've got Docker Desktop, you should be able to open up something like this. Where'd you go, Docker Desktop? There we are. All right. So, Docker Desktop. When it opens up, you're going to see a bunch of things. What I'm going to need you to do to get going is to go to Images. All right, so you see this tab over here, click on Images, and we need to get a copy of that particular image, that particular container that we're starting up every time we run on DataHub. So the best way to do that, in my opinion, is to use this built-in terminal tool right here. Okay? So if you go to this terminal here, you're going to see something that looks like, if you have a bash shell on your computer, that's essentially what you're doing, but here inside the Docker environment. Okay, so you're going to type Docker pull and paste that address that we got out of DataHub. Remember? This address says this is where the data science notebook is stored. And we're going to get a copy of exactly the same Docker image that was being used by UCSD to run DataHub. Okay, so this is going to take a second to run, but we're going to let it go. So right now it's downloading a couple of gigabytes of stuff. And again, what it's downloading is basically a complete Linux operating system, a complete set of Python that's exactly the right version that matches what we're using on DataHub. It's downloading a bunch of very common Python tools that you will be using in this class. And again, this, when we run it, is going to be run as an operating system inside your operating system. It is going to be a container which has all of its own stuff, and it's running, and the things it's doing does not affect your local computer. It's running in a completely sandboxed, totally isolated way from whatever is actually happening on the rest of your computer. So Docker containers in this way are also highly secure. If you run software inside a Docker container, it's pretty hard. You have to do a lot of dumb stuff to have something happen inside a Docker container that's going to, like install malware on your computer at large. This stuff's all sandboxed. It is totally isolated from whatever else is going on in your computer. Okay? Along the lines of that, what we're going to have to do is we're going to have to tell it how to save things on your local computer. Because what we're going to be doing is running an isolated sandboxed operating system and all its own tools. It doesn't have access to the rest of your files. So when you're working on your brand new COGS 108 DataHub setup on Docker, we need a way to actually go ahead and link things so that you can save your work onto the file system that resides on this laptop. Okay? So let's get rid of this. We're on images still here, right? So what you can see is previously we did not have 2025.1.stable before, but we have just downloaded it by making that pull. Okay, you can see I already had installed previous versions of COGS 108, but this version of COGS 108 is different. So an image is just like the name says, it is an image of how we're going to set up an entire operating system in Python environment. Okay, well now we need to turn it into a running container, something we can start and stop at will. Okay, so we're going to start it by pressing the run button. Now when the run comes up, we're ready to run a new container. And there are a whole bunch of optional settings here. I want you to click over and open those optional settings. So first off, let's give this a name. COGS 108 _ fall 25. To be clear, I don't think you're allowed spaces or anything like that in your container name. So use an underscore, copy this, call it whatever you want, but you can make bad container names that are not allowed here. Okay, so we need to give it some information. I want you to put 4 8s here in the host port, 8888. There's a reason for this. This is one of those things that you probably may not already be familiar with about operating systems, is that they open up communication ports. Like for instance, when you go grab stuff off the web, that may happen on port 22, for instance. Low numbered ports are reserved for lots of things. High numbered ports are kind of for your use. So Jupyter likes port 8888. Because we're using Jupyter notebooks for this class, I am setting you up to use Jupyter notebooks by putting 8888, 4 8s here in the host port. Okay, remember when I said we need to tell this thing specifically how it's going to save files outside the container? Well, if you click here, you will get a file dialog box that will let you select some location somewhere in your file system that's going to be accessible both inside your Jupyter notebooks, and it's a way in which you can save your work and be able to look at the results of your work outside of this Docker environment. Okay, so pick a relevant directory. I don't care what it is, just make sure you pick a directory that it's going to be good for you in doing the work in this class. Okay, so this directory is whatever you need it to be. It's going to be different than my particular directory because this is about what's on your local machine. However, this part here is going to be the same for everybody. Okay. Whoops, I can't type. I need a slash there. Note the direction of the slash. It is a forward slash, not a backslash. And note that we are /home /Jovian, spelt Jovyan. Okay, this is what's inside the container. This is the home directory inside the container that we are creating. It's got to be called this. Okay, once you've done that, you're going to click Run. And what you're going to see is Docker is spinning up that image into a usable container. It's loading up this copy of the Linux operating system. It's getting all the Python ready. It's launching the Jupyter notebooks inside this little sandboxed container. But now what we need to do is we need to open up our own web browser on this local computer and access the container through port 8888. How do we do that? Well, if you just click on this link or copy paste it into your browser, yay, it doesn't like to work. Thank you very much. Why are you doing this to me? Because the link is broken. Oh wait, because I'm a doofus. Don't use this one. use the 127 link, 127.0.0.1 and then some stuff. Use that one. That's the correct one. Good job, Jason. All right. Yay, it worked. Okay, let's take a look at your web browser. Your web browser should be pointed at 127.0.0.148/lab. This is a locally running version of your same environment that you would see here on DataHub. DataHub environment, this is happening. This is your web browser talking to servers in UCSD Supercomputer Center. This one is your operating system browser talking to a fake computer, a container, inside your own machine, this containerized UCSD ETS data science notebook, along with its own operating system. So if I open up a notebook here and I do things like whatever, import pandas as PD and ask for what version number the pandas are. So pandas is a library we'll be using a lot. I see this is version 2.23. And if I do the same thing here, why are you bugging me? There we go. I also have a notebook and 2.23. These versions exactly match because the setup, the operating system, the Python version number, the pandas version number, they are identical between what we set up locally and what we did here. Now, some caveats. If you're operating locally, things are not going to work with getting and fetching assignments, I believe. Now, I could be wrong, but I'm pretty sure that you're only going to be able to fetch and submit assignments when you're on DataHub. Somebody correct me if I'm wrong. Let me know if it does actually work. It's not configured yet. This is way before a quarter is starting, so I don't have it set up, so I can't test it for you. Okay, so do your assignments by default on DataHub, please. Okay, but you could always, if DataHub fails, you want to manually download your assignments and manually upload them again at the end. Well, at least you got a working version down here on your own laptop. And again, what I think this is really useful for is making dead sure that project work operates properly, okay? And being able to do projects outside of the DataHub environment. All right, that's all I've got. Thank you so much, everybody. Have fun. Talk to you later.